Good morning friends, and welcome again to another class of Parijat sir classes. And today we will be discussing another new chapter of class 12th, which is the current electricity. As you all know, this is a very important chapter of class 12. So this chapter will be starting in two phases, and in every chapter what we will do is that we will discuss the important sections of the chapter along with some numericals. Okay, so all the important topics which will be covered, which are important for your board examination, especially I have kept the complete coverage of the topic in such a way so that your board, especially your board examinations, because maximum students are commenting regarding to upload videos so that it covers up their board examinations. So the board examinations, okay, the ISC, CBSE, total board examination will be covered up. Plus I am covering up some important questions which will be the topics for the IIT, JEE and all other entrance exams, any entrance exams. So I would request you to please continue watching the video, pause the video, watch the video carefully, and please watch the video completely. Do not watch the video half. Please watch it completely in sessions, and then only you will be able to understand the full chapter. And because I will be dealing all the important topics plus all the important questions which are very much a part of the board examinations, so please keep watching the complete topic of this, right? So let's get started. And before I start, once more I would like to request you, please keep watching Parijat sir classes, and please like, share and subscribe my channel. Like, share and subscribe my channel so that it can grow and it can reach to maximum of the students who need this type of classes. Okay, so let's get started. So first of all, see, let us make you introduced to the term electromotive force, EMF, electromotive force. What is it? So it is defined as, for example, like this is a battery and it is in the open circuit. That means I have not connected anything. This is the positive, this is the negative. Okay, so the maximum potential difference, which can exist between the two electrodes of a battery, that is only called EMF. That will be called as EMF. Okay, the maximum potential difference which will be there between the two plates of the battery in an open circuit. Please mind, I have not connected anything to the battery, so it should be in the open circuit, and that is called the EMF. Okay, electromotive force. Now the SI unit of a cell, that means the potential, is volts or joules per coulomb. Please remember, it is potential also is work done per unit charge. So it is also joules per coulomb, joules per coulomb. We have already done this in the potential chapter of the class 12. Okay, so please watch that video so you will be able to understand how this came. Next is electric current, which is I. Rate of flow of charge. So it is I equal to Q by T. I is equal to Q by T. What is Q? Q is the charge in coulombs, and Q is equal to N into E. This N is the number of electrons, N is the number of electrons, and E is the charge of an electron. E is the charge of an electron whose value is minus 1.6 10 to the power minus 19 coulombs. Okay, so this is how we find the charge, and then we divide the charge by the time, and this time, please mind it, the time T is in seconds. The time T should be in seconds. Unit of electric current is ampere. SI unit of electric current will be ampere. Okay, and direction of current, very important. Direction of current, okay, it is from the positive terminal of the battery to the negative terminal of the battery. Positive terminal to the negative term. That means it will come out from here, it will come out from here, the current I, and it will enter here. It will enter here. Okay. So current is a scalar quantity. Current is a scalar quantity. We are interested only in the magnitude of the current. Next comes drift velocity. What is drift velocity? It is the average velocity of the free electrons which get drifted towards the positive end of the conductor under the influence of an external field. Okay, for example, like here is an external we have given. Suppose this is a conductor. This is the positive terminal of the conductor, the negative terminal. Okay, now this is the electric field. So the velocity with which the charges, this is the electron, the velocity with which it will be drifted towards the positive end of the battery of the conductor under this field. The velocity with which this electron, free electron inside the conductor, will move towards the positive end of the conductor under the influence of the electric field, that is the drift velocity, and its value is given as E by m. E is the electric field, E is the electric, small e is the charge of the electron, and m is the mass of the electron. And what is this tau? What is this tau? Tau is the time, average collision time between the two electrons. How? Suppose this electron is also going, so they are, while going they collide. Okay, while they, this electron, here is an electron, they will collide, they will collide, they will collide, they will collide, and then they will reach this. So this collision time is called a tau. So it is E by m into tau. Clear? Next is mobility. The magnitude of the drift velocity of charge per unit electric field. So this is mobility, which is the drift velocity by the electric field. Drift velocity by the electric field. So this is the value of the mobility. Q into tau by m. Q into tau by m. Right? This is the value of the mobility. Let's see the next thing. Relation between current and drift velocity. Relation between the current and the drift velocity is very, very important. So let us see how do we do this. So let us consider a conductor of cross-sectional area A. Cross-sectional area as A and the length as L. The length as L. It is connected to a battery of potential difference V. So the electric field apply is from positive to the negative. Electric field, see, positive to the negative. So current is coming out from the positive. Okay. Now free electrons, they move towards the positive terminal with a drift velocity Vd. So imagine that if A is the cross-sectional area and L is the length, so what is the volume of the conductor? The volume of the conductor is A into L. This is the volume. Now if N is the charge density, that means charge per unit volume. What is N? N is the charge per unit volume. It is the charge per unit volume. Okay. So what is the total charge? It will be N into the volume. The total charge will be N into the volume. So this is the total charge. Total number of free electrons will be ALN. This is the total charge inside the conductor. So what is the this is the total number of electrons. Now what is the total charge? Each electron is E. So these many electrons will have total charge of this much. Now what is the time taken by the electron to cover a length L? It is L equal to L by the drift velocity. Okay. Now we know I equal to Q by T. So this is my total charge. ALNE, and this is the time. This is the time. So it comes out to be NANEAVD. So this is the relation between the drift velocity Vd and the current I. Drift velocity and the current I. Clear? Next is Ohm's law. The current flowing through a conductor is directly proportional. Current is directly proportional to the potential difference applied. So more the potential difference applied, more is the current flowing. Okay, or we can write V proportional to I. But please understand that you have to keep physical conditions like temperature, mechanical strain should be kept constant. This is the condition for Ohm's law. This is the conditions for the Ohm's law. Condition for Ohm's law, like you have to keep the temperature, mechanical strength should be kept constant. Okay. Now removing the constant, we will write V equal to IR, where R is equal to V by I, which is a constant, and that is called the resistance of the conductor. That is the resistance of the conductor. So if I plot V versus I, the graph should be a straight line because V is proportional. V is proportional to the I. V proportional to the I. Okay. Now remember, slope of this I versus V graph. This is the slope of this. Slope of I versus V graph will give you what? Conductance, which is opposite of the resistance. Please remember, slope of this, 1 minute, let me write it here. Slope of this I versus V graph, that is the slope of I versus V graph, that is delta I by delta V, is actually the conductance, and which is 1 by R. Clear? Now electrical resistance is what? So resistance, what we got, is the ratio of the potential difference across the ends of the conductor to the current flowing through it. This is the formula for the resistance. Okay, SI unit is what? Ohms or volt per ampere. Now factors affecting the resistance of a conductor. The resistance of a conductor will depend upon what? It is directly proportional to the length of the conductor. That means a conductor which has got more length will have more resistance, and less length will have less resistance. Second, resistance is inversely proportional to the cross section of the wire, cross section of the conductor. That means thicker the cross section, less is the resistance. Third, it is directly proportional to the material of the wire. So better it is a material, better it is a conductor, more is the resistance. Okay. So combining all, we will get R equal to rho L by A, where rho is the specific resistance of the conductor. Rho is the specific resistance of the conductor. This rho is what? Specific resistivity of the conductor. Okay. Now suppose I want to find out the definition of the specific resistivity. I want to find out the definition of this. So in that formula, if I put L as 1, A as 1, then R is coming rho. So what can I write? Specific resistivity is equal to the resistance of the wire, of the conductor, having unit length and unit area of cross section. Length unit and unit area of cross section. And remember, the SI unit of resistivity is ohm meter. Please understand this. SI unit of resistivity is ohm meter. Okay. The resistivity of a conductor depends on the material of the wire and not on the length of or area. Please important. Area. Resistivity will not depend on the length or area of the conductor. Not depend. Now let us see. Resistivity of silver is given, suppose 1.6 10 to the power minus 8. What does it mean? So we know the resistivity is equal to the resistance. That means this will be the resistance only. This will be the resistance only if I use a conductor of unit length and unit cross sectional area. That means area of cross section 1, and if the length is also 1, that means this is the value of the resistance. This is only the value of the resistance. Clear? Let us next come to the next point, that is current density. What is current density? It is defined as the current per unit area. Current flowing per unit area of the conductor. So it is a vector quantity and is in the direction of the positive charge. So current density is in the direction of the positive charge. So this, we know that I is equal to NEAVD, okay, by the area. So this is I. We know I is equal to NEAVD. So J will be I by A. So AA cuts. So this is the formula of the current density. This is the formula of current density. Okay. So remember this, current will be equal to, what is the current? Current I can find as the current density into the area, and that is why we can use this formula also. I equal to integration of J dot ds. SI unit of current is, SI unit of J is ampere per square meter. Ampere per square meter is the SI unit. Please keep note of all these things. Very important. Conductance is the inverse of the resistance. Conductance is the inverse of the resistance. So SI unit will be mho. Resistance is ohms. So conductance will be mho. Electrical conductivity. Conductivity is opposite of the resistivity. So see, resistivity is opposite is conductivity. So resistivity was what? Ohm meter. So it is the opposite of this. Okay. And this is how the current density and the conductivity are related. Current density and the conductivity are related by this formula. Clear? Okay. So let's see the next part, which is dependence of resistance on temperature. How will the resistance depend on the temperature? So see, this is the formula where the resistance, how it will depend on the temperature. Suppose this is the initial resistance at 0 degree. This is the resistance at 0 degree Celsius. RO is what? Resistance at 0 degree Celsius. And RT is the resistance after you heat it through T degree Celsius. After you heat it at T degree Celsius. So what is the relation between them? RT equal to R01 plus alpha T. And what is alpha? Alpha is the coefficient of resistance. Alpha is the coefficient of resistance. Please keep this in mind. So this is the formula between the resistance and the temperature. Next we come to the color coding. So for the color coding, see, on a wire, how many types of colors can be there? Suppose this is a conductor. Suppose this is a conductor. So this conductor has certain, suppose, colors. Okay. Out of these, as you can see, these are the colors. These are the colors. Black, brown, red, orange, yellow, green, blue, violet, grey, white, gold and silver. Okay, and you have to remember in such a way. BB, so you have written it. See how to remember this list. B Roy, B for black, brown, Roy, red, orange, yellow, red, orange, yellow. Great Britain, great for green, Britain for blue, very, violet, good for grey, wife is white, then G for gold and S for silver. So if you see this, it is written here, okay, and their numbers are also mentioned, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, B Roy of Great Britain, very good wife, okay, wearing gold silver necklace. B Roy, Great Britain, very good wife, wearing gold silver necklace. So last one is gold. Here is a gold and here is silver. So now see, how do we choose? So these are the multipliers, these are the color codings. Gold is plus minus 5, this is a plus minus 5%, silver is plus minus 10%, and no color is plus minus 20%. Okay, so let us now see, suppose a conductor has colors. What colors? So first let me show. There is a yellow color, second, suppose there is a red color, third, suppose there is an orange color, and fourth, there is a golden color, so what will be the resistance of this? So please watch how to do this. Okay, so please watch how I am doing this. So first color is what? It is yellow. So what is the value of yellow here? See, yellow is 4, so this is 4. Second color is red. So where is red? Here is red. The red is 2. That means 2. Okay. Now it is an orange color. So for orange color the multiplier will come. For the first two colors, you have to choose the value. This is the first two colors. Okay. Then this is for the third color. And this is for the fourth color. So third color says it's orange. So where is orange? Here is orange. 10 to the power 3. So we will write into 10 to the power 3. Okay. And fourth is gold. So what is gold telling? It is plus minus 5%. So this is the value of the resistance of this conductor. This is the value of the resistance of this conductor. That means here we are getting 42 into 10 to the power 3 plus minus 5% is the resistance of the conductor. Okay. Next, the resistance is value is given. See, value is given how much? 2.4 10 to the power 6 plus minus 5%. So let us draw the color codings on that conductor. What color codings will be there? Okay. So first of all, it is 2. This will come. It is given 2.4, okay, into 10 to the power c. So see, That means 2 point. So I can write this as 24 into 10 to the power 5, right? Plus minus 5%. So 2, 4. First is for 2. What is 2? 2 is for red. That means the first color which will come is red. This 2 is for red. Now 4. 4 is for yellow. This 4 is for yellow. That means here is a yellow strip. Then third, 10 to the power 5. So 10 to the power 5, as you can see, it is green. 10 to the power 5 means it is green. So here a green strip will be there. Next is plus minus 5%, which is gold. So we will use the golden color here. So this is the color coding of this conductor. Clear? This is the color coding of the conductor. So let us see, friends. Next we have got the numericals. Now little bit theory is still left, so let us see. Okay. So see, let's watch this part. That is, if resistances are taken in series, see, this is the connection of series. That means one resistance at a time. This resistance connected to this resistance, connected to this resistance, and connected to the battery. Okay. So the first resistance is connected to the battery is positive, and the last resistance, this end, is connected to the battery's negative terminal. Clear? That means when the current is passing like this, it is flowing equally through all the resistances. So in this case, what happens? The current remains the same. Potential difference varies. So see, potential, the total voltage V is divided as V1, V2 and V3 among the three resistances. So I can tell that in this case, in the series, the potential difference will be divided, but the current will be remaining the same. Okay, and net resistance in series is the sum of all the resistances. The net resistance in series is the sum of all the resistances. Now let us come to the parallel. See the parallel connection. Each and every resistance is connected directly to the battery's positive and the negative. See, each and every resistance is connected to the battery's positive and the negative. That means the potential of the battery will be directly applied to each of the resistances, and the current which will come, it will be flowing in three different paths. That means current will divide, but the voltage of all the resistances will be same as this volt, because they are directly connected to the battery. And the net resistance in parallel is this formula, as we have already done in class 10. So this is the net resistance in case of the parallel connection. Clear? Let's see. The next topic is terminal voltage. So what is terminal voltage? So watch here. Terminal voltage means the potential difference between the electrodes of a cell in a closed circuit. That means when no current is drawn from the from the cell, that is open circuit. When no current is drawn from the cell, that is EMF. That is EMF. Okay. EMF is in open circuit. Mind it. EMF is in the open circuit when you don't draw any current, and terminal voltage is in a closed circuit when there is a current. So watch here. Suppose this is a battery cell of EMF E, internal resistance R, so this is the battery having an internal resistance R, EMF E, connected to an external resistance capital R, connected to external resistance capital R. So when current is coming out, see, first of all, inside the battery there is an internal resistance, so there will be a drop of IR. There will be a drop of IR, and this drop is called the internal drop. This is called the internal drop. Mind it, internal drop. So how much potential is left for the external resistance? This much. E minus IR. E minus IR is the potential left for the external resistance. Okay. So I can see that the external voltage which is V, is less than EMF. External voltage V is less than the EMF. Okay. So more the internal resistance, less will be the external potential difference. And more will be the internal drop. Okay. Factors not affecting the EMF of a cell. Okay. So on what factors the EMF of a cell will not depend? Number one, quantity of electrolyte. So how much quantity of electrolyte you use will not affect the EMF of a cell. Second, size of the electrodes, whether you use a bigger electrodes, whether you use a smaller electrodes, or you use a bigger electrodes, the EMF size will not vary. Distance between the electrodes, that means this distance will not be responsible. Distance between the positive plate of a cell and a negative plate, this distance will not affect the EMF of a cell. So EMF here is this, and here will be also this. Clear? Next, when current is drawn from the cell, when you take current out, like here, when your current is drawn from the cell, then terminal potential of the cell is less than the EMF of the cell. Mind it, the terminal potential will be less than the EMF when current is drawn from the cell. Drawn means you are using the battery, current is coming out of the battery. Okay. When a cell is charged by some other source, for example, when you are charging a cell, that means you are sending the current to the battery, so that is called charging. And when you are charging, so remember, the terminal potential will be greater than the EMF, Direction of current inside a cell is from positive plate to negative plate. This already we have done. Now a very important topic. See, when we connect many cells in series, suppose we have connected, watch the connection, it is positive, negative, positive, negative. In series we have connected positive, negative, and there is a current flowing through the cells. Internal resistance of this cell is R2 and this is R1. So remember, when the cells are connected in series like this, okay, in what way? Positive, negative, then positive, negative, then positive, negative, like this. In that case, the equivalent EMF will be added up. the equivalent EMF will be added up and the equivalent resistance will also be added up. But when the cells oppose each other, for example, positive, negative, and then see negative and positive. So they oppose each other. Watch here. They oppose each other. Okay. So let this be E1 internal resistance R1. This is E2 internal resistance R2. They are connected in series, but they are opposing each other. So equivalent resistance will be subtracted. Equivalent EMF will be subtracted. But the equivalent resistance will always be equal. Equivalent resistance will always be equal. Clear? Let's see the next slide, what it has got. 1 minute. Okay, so in the next slide, please watch here. We are showing that if we have cells in parallel, for example, that was in series, that what we did was in series. Please watch here, this is in series. Now we are going to see what happens if the cells are in parallel. So watch here, this is a cell and this is a cell in parallel. EMF E1, internal resistance R1, EMF E2, internal resistance R2. Current is coming from here, entering the negative of both and coming out. Okay. Please remember the equivalent EMF will be E1 R2 plus E2 R1 by R1 plus R2. Net EMF in parallel will be E1 R2 plus E2 R1. Net equivalent resistance for the internal part will be 1 by R1 plus 1 by R2. Clear? Now watch one thing. If the EMF of the first and the second are equal to E, EMF of the first and the second are equal to E, and the internal resistance of the first and second are equal to R, then this formula will get converted. So in this case, watch here that the equivalent resistance will be 1 by R1 plus 1 by R2. Okay. And now here, if you take the value of E1 and E2 as E and R1 and R2 as R, so see, this equivalent resistance will then become E1 is E, R1 is R, E2 is E, R2 is R. So this one will become, this is 2ER by 2R. Okay. So this is actually how much coming. This will be becoming as E. Net equivalent EMF in parallel will become E. Net equivalent will become, because this will be 2ER by 2R. So the net equivalent EMF will be E. Okay, and net equivalent resistance will be 1 by R plus 1 by R, which is 2 by R. Clear? And please remember, this relation is very important. E equivalent by R equivalent. E equivalent by R equivalent will be E1 by R1 plus E2 by R2, and this continues. Clear? Next, another topic, that is mixed grouping of cells. So watch here one thing, that is, suppose we have taken n cells of EMF, each EMF will be E. Each cell's EMF I am taking as E. So I have taken n cells. This is n cells in series. And here I have taken m rows. This is how many rows? M rows. Okay, m rows. Each row has got n cells. Each row has got n cells. N cells. Clear? So in one row, what is the total EMF NE? Okay, and what is the total internal resistance in one row NR? Now, so it is coming out to be NE in one row, NE in the second row, NE in the third row, in this way, NE up to the mth row. So total EMF, if you take, as I told you, that if suppose you have got, here you have got NE, 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 and this continues, okay, up to the mth row. We know, just now we have seen that if they are in parallel, and if the value of each EMF is E, so equivalent EMF, so whatever you connect will always be E. That means the total equivalent EMF in parallel will be how much? N into E. Total EMF in parallel will be N into E. This is the total EMF in parallel. Now, what is the net resistance in one row? It is NR, and in this way, if it continues, see NR, NR, NR up to M rows. If these are the resistances, so the total resistance will be what? How much? Up to M row, it will be M by NR. M by NR. So R equivalent will be NR by M. Correct. So total current will be total EMF, and there is the external resistance R. So what is the net resistance? Net total resistance will be this. So what is the total effective current will be? Total EMF by the total resistance, which is coming out to be this, and which is at the denominator we can write like this. Now if I want the current to become maximum, so the denominator has to be minimum. That means this part has to be 0. That means MR is equal to NR. That means for maximum current, I want the value of the external resistance connected should be NR by M. Should be NR by M. Please remember this. The value of the external resistance connected should be NR by M. Clear? Now friends, let's see some of the important numericals, how to solve it. Let's see this. First of all, they are showing that this is a circuit connected, as you can see, and here is the capacitance 2 microfarad. Here is the capacitance 2 microfarad. They are telling what is the energy stored in the condenser, that means the capacitance. Okay, so watch here. When the current is passing, the condenser is storing some energy, and when it will store full energy, see, it is storing full energy, so it will not allow any current to pass through it. It will not allow any current to pass through it because it is full charge, full energy. So the total current flowing in the circuit will be along A, B, C, D. Okay, so now these three resistances are in series. So what is the total resistance? It will be 2 plus 3 plus 5, which is coming to be 10 ohms. That means the condenser is connected to a 10 ohm resistance. Here is the condenser. This is the 10 ohm resistance, current passing through this is 2 ampere. So what is the voltage developed across this? What is the voltage V? So V is equal to I into R. So 2 into 10. So V is coming 20 volts. That means the condenser is actually connected to a voltage of 20 volts, and the value of C is given to you 2 microfarad. So we know energy is equal to half CV square. So half, it is given 2 into 10 to the power minus 6 into V square is 20 square, which is coming 400 into 10 to the power minus 6. That means 4 into 10 to the power minus 4 joules. This is the energy stored in the condenser. This is the energy stored in the condenser. Clear? Next, let us see. This is an infinite series connection given. Infinite series connection given. So, whenever an infinite series connection is given, please watch carefully that this connection, whichever part will be repeating, see 1 ohm and 2 ohm, 1 ohm and 2 ohm, 1 ohm and 2 ohm are getting repeated. So your target will be to write the, draw the figure like this. This is 6 volt, 1 ohms, this is 2 ohms, this is 1 ohms, and now your job will be to connect. See, this 1 ohm and 2 ohm are getting repeated every time, so your job will be to connect a resistance here, which will be the combination of this part, which will be the combination of this part. Let this part be R. Okay, so now please understand one thing, that is this R and 2. R is what? The net resistance of this part. Okay, this R and 2 are in parallel. So 1 by R plus 1 by 2, which is 2 plus R by 2R. So it will reverse. Okay, and with this 1 ohm is getting in series. That means 2R by 2 plus R plus 1 is the total resistance, and remember it, this total resistance is equal to the value R, because this R is very big compared to the total resistance. Okay, this R is very big compared to the total resistance. So we should do this 2R plus 2 by R, 2R by 2 by R, 2 plus R plus 1 should be equal to R. So let us now do this calculation, which is 2R plus 2 plus R by 2 plus R is equal to R. That means 3R plus 2 is equal to 2R plus R square. That means R square minus R minus 2 should be 0. That means if I calculate the value of R will be, using Sridharacharya, R will be 1 plus minus root over 1 square plus 4AC, which is 8, by 2A, which is 2. 1 plus minus, this will be 3 by 2. So R, taking the positive sign, we get it is 4. So R is coming 2 ohms. This is the net resistance of this circuit. Clear? This is the net resistance of this circuit. Next, let us see, friends, what else is there. So we have got this combination of the network. Let us calculate the measure of the current. So measure of the current by the ammeter. Okay, so this is the ammeter. So how much current will be coming out? So for that we have to see what is the connection and the net resistance of this. What is the connection and net resistance of this? Okay, so let us first watch out how to do this calculations of the circuit calculations. Okay, let us see how to calculate the resistance in a very effective manner. So if you watch one thing, what I can do is that this particular part, please watch this particular part, because there is a similarity in the circuit. Similarity means I can easily draw a line which can cut the circuit into two equal halves, mirror images. Okay, so what I will do, because it will cut into two equal half of the mirror images, so those points which are lying on that mirror line, points lying on the mirror line should be having equal potential difference, should be having the equal potential difference. Clear? So if I watch this part carefully, please see what I can do. Suppose I name this point as A and this point as B. Okay, can I bring this point to this and this point to this? I can easily bring this point to this and this point to this. So how will the circuit look? How shall the circuit look? See here, the circuit will look like this. The circuit will be looking like this. And here is the 10 ohms. It will look like this. So this is 10, 10, 10, 10. This is 10. And this is 10. So the inner part of this will be 1 by 10 plus 1 by 10, that is 2 by 10. Isn't it? Inner part is 1 by 10 plus 1 by 10, okay, which is 2 by 10, 1 by 5, that means 5 ohms. So this part is 5 ohms and this part is also 5 ohms. So 5 plus 5 is 10 ohms. Okay, 5 plus 5 is 10 ohms. And now if I draw the circuit, this is 10, 10 and 10. So what is the net resistance? It is 1 by 10 plus 1 by 10 plus 1 by 10, which is 3 by 10. So this will be 10 by 3 ohms. Therefore, the current will be V by R, which is 12 by 10 by 3, which is 36 by 10, 3.6 ampere. This is the current flowing in the network. This is the current. Next, let us see this particular network, and they are telling what is the effective resistance of the network between A and B. So we will be finding out basically RAB. This is what we have to find out. Okay, so watch one thing. If I take this line, this line, all the points, isn't it giving a mirror image? It's a mirror image. So as I told you that all the points lying on this mirror image line, all the points lying on this mirror image line will have the same potential. That means I can write VC minus VD equal to VD minus VE will give you 0, will be 0 voltage. So if they are 0 voltage, what is the use of keeping this connection? What is the use of keeping this connection? So we should do one thing, that is we should erase this connection out. We should erase this connection out. Okay, there is no use of keeping this connection. We should erase this connection out basically. So, and if this connection is erased out, then what we can do is that we will be also removing this part, and then this will look like this. Sorry, this will look like this. Let me okay. So the circuit will now look like this. Yes, this is the circuit which it will look. That means, watch here, this part is in series. This part basically is in series. This part is also in series. Okay, this is in series because there is no use of connecting them. This is in series. So what we can do is we can also connect it like this. So we can also take it like this, or else what we can do another way, because I think this will make it little bit more simpler. If I can connect it, please watch one thing, that is one minute, let me rub this. Okay, so now let us draw this figure. Now let us draw this figure like this. Because this was in a same potential, so we have removed this line. So when we remove this line, we can draw the circuit like this also. We can draw the circuit like this also, and so this, yes, and this. We can draw the circuit like this also. Clear? So watch now one thing, that is this part and this part. How does it look? It looks, the upper part is 2R series, lower part is 2R. So 1 by 2R plus 1 by 2R, which is 2 by 2R, which is 1 by R. So the net resistance will be R. Okay. Similarly, this is also R. This is also R. So what is the effective resistance? That means if I draw it, it looks like this. Okay, here is the resistance R, and here is the resistance R. So here is A, and here is B, and here is R, and here is R. So what is the net resistance? 1 by R plus 1 by R, which is 2 by R. Therefore R is equal to R by 2, which is 0.5 R. And this is the answer of the effective resistance. This is the answer of the effective resistance. Clear? Let's move on to the next part. See, first of all, they are telling that between A and B, here is A and here is B, what is the net resistance? So watch here, current will come like this, some part will go here, some part will come here, some part which will try to go to this part will not be able to go out, so it will again return back to this part, and some part will go here, some part will go here, they will meet here. Now some part which will try to go here, there is no path, so it will again return back and meet with this, meet with this and come back. This is the net. That means this part has got no use, this part has got no use. Clear? So if I redraw the figure, it will be like this. This is the A, this is the B, so all are 10 ohms. So basically, see, this is 30 ohms, so 30 and 10 are in parallel. So which is 1 plus 3, 4 by 30, so 30 by 4, it is 15 by 2 ohms, right, this part. Now with 15 by 2, this 10 ohms and 10 ohms will be series. This is 15 by 2, this is 15 by 2. Now 15 by 2 plus 20 is our net resistance. They are in series. plus 20. So 15 plus 40, that means 55 by 2. So it is coming 27.5 ohms. This is the answer of the first part. This is the answer of the first part, which is coming RAB 27.5 ohms. Now come to R between A and C. Between A and C. Okay. So between A and C. So first of all, let me make the things clear. Let me make the things clear. So okay. So now they are telling between A and C. Clear? So between A and C, that means I want to calculate it. I want to calculate it between this and this. That means when the current will start flowing, from here, some part will go here, some part will go here, That means this part will be obsolete and this part will be obsolete now. Clear? These two parts will be obsolete now. So if I can remove these two parts, and little bit draw it, so it will look like this. That means this 20 ohms, this is 20 ohms, and this is 20 ohms are in parallel. So what is the connection? Calculation: 1 by 20 plus 1 by 20, which is 2 by 20, which is 1 by 10. So what is this? 10 ohms. Now with the 10 ohms, this 10 ohms, with the 10 ohms, now see this 10, this 10, this 10 and this 10 are in series. Therefore the net resistance will be 10 plus 10 plus 10, which is 30 ohms. Clear? This is the solution of the second part. So RAC will be 30 ohms. Clear? Next, see the sum. This one. Find the net resistance between A and B. Find the net resistance between A and B. So this is our A and this is our B. Okay. So what we can do here, watch one thing, that is this part we can bring it and connect to this part. We can bring it and connect to this part. So how will it look? Okay, this part, point C, where point C is coming onto point D. Clear? This is point E. This is 3 ohms. This is 6 ohms. And now from point, this is okay, and see, from point C, point A came out, and point D and point E, suppose point, this is F. So D and F, this is 8 ohms, and this is F. So basically this is 30 ohms. And now from F there is a point B coming out. So they are telling find the resistance between A and B. Okay. So see, 6 ohm and 3 ohm. This 6 ohm, this part is in parallel. So what is the resistance? 1 by 3 plus 1 by 6, which is 2 plus 1, 3 by 6. So it will come 2 ohms. That means this is 2 ohms. Now 2 ohms and 8 ohms are in series. 2 ohms and 8 ohms are in series, so they will add up to 10 ohms. So the upper part is 10 ohms and the lower part is 30 ohm. So what is the net resistance? 1 by 10 plus 1 by 30, which is 3 plus 1 by 30, 4 by 30, 2 by 15. Therefore R will be 15 by 2, 7.5 ohms. Answer will be 7.5 ohms. Clear? Now let us do this sum. Here are two batteries given. One EMF is 20 volt and the other EMF is 8 volt. So see, 20 volt is more powerful than 8 volt. So the current will start to flow like this. Current will start to flow like this. Okay. That means I can tell the two cells are connected opposing to each other. So what is the net potential difference? E1 minus E2, which will be 20 minus 8, which will be 12 volt. What is the net resistance? It will be 3 plus 1, 4 ohms. So what is the net current? It will be V by R, that is 12 by 4. It will be 3 ampere is the net current. Now watch here. They are telling what is the potential between A and B. What is the potential between A and B? So in the 3 ohm, what is the current coming? 3 ampere. So what is the voltage drop across this? Will be 3 into 3, which is 9 volt. 9 volt. So watch in the upper part. The point A is connected to the battery, upper battery directly. That means this is 20 volt. Here is a 9 volt drop. So out of 20, 9 volt gone here. So here will be the remaining voltage, 11 volt. Right? So that means VA minus VB will come how much? It will be 20 minus 9, which is 11 volt. If I would have come from the down part, current is entering into the battery. So potential drop, here potential drop will be how much? 1 into 3, current is 3 ampere. So voltage drop here will be how much? 3 volt. So the potential difference between A and B, it will be 8 plus 3 volt. Why? Because current is entering into the battery. So terminal potential will increase. So anyhow you come either from the upper part or from the lower part, the voltage between A and B will always be 11 volt. Clear? Next, see the next circuit here. What is the next circuit given? Find the magnitude of the current supplied by the battery. Also find the potential difference between A and B. Okay. First of all, let us see the resistances in the upper part. This part, they are series and they will be parallel. So net resistance 1 by 9 plus 1 by 9, which is 2 by 9, 9 by 2 ohms. Okay. Therefore current V by R, which is 36 by 9 by 2, which is 36 into 2 by 9. So 8 ampere is the current flowing in the circuit. This is the magnitude of the current. So current we got 8 ampere. Now they are telling what is the potential between A and B. Potential between A and B. So see, the upper resistance is, if I draw it like this, this is 9 ohms, this is 9 ohms, 36 volt. Okay. So current coming out is how much? Current coming out is 8 ampere. Current coming out is 8 ampere. So voltage across 9 ohm is 36 volt. So how much current will enter here? Current which will enter here will be 36 by 9, which is 4 ohms, 4 ampere. So current entering here will be 4 ampere also. Correct? So now watch one thing. When the current of 4 amperes enters here, please watch one thing. When the current of 4 amperes enter here, what is the drop here? The drop here will be how much? 4 into 3, 12 volt. Okay. Now here was 36 volt. This point was connected to the battery, main battery, so 36 volt. Here there is a drop of 12 volt. So how much voltage is there remaining? That is, here it will be 24 volt at A. That means VA is actually 24 volt. Now let's come to the next one. Down part. Through 6 ampere, how much current is going? Through 6 ohms, 4 ampere. So what is the drop in this 6 volt? It is 24 volt. So how much voltage is remaining here? It is 36 minus 24, that is 12 volt. Therefore VB is coming 12 volt. they told me to find VA minus VB, which is 24 minus 12, which is 12 volt, and this is the final answer. Correct? This is the final answer. So friends, let's see next sum. What is given? Find the minimum number of cells required to produce an electric current of 1 ampere. That means I want a total current of 1 ampere through a resistance of 30 ohms. Are given that EMF and internal resistance are 1.5, this is E and this is R. Okay, so we have already done a relation. That means let n cells be in series. Let m cells let m rows be there. So net EMF in one row will be what? NE. Net EMF in M rows will be what? NE only, because they are connected in parallel. Please watch this particular part, so you will understand properly what am I trying to tell here. Please watch this part very carefully. Please watch this part. Okay, for this particular sum, please go to this part and watch the sum. So now total resistance, we have already see, this is the equation which we have already taken up from that part. Okay, they are telling that I is given as 1.5 ampere. M is the number of rows, I don't know. N is the number of cells connected in series, I don't know. E is the EMF which I know, 1.5. This is 30. Internal resistance is 1. So 1 R, 1 N. Okay. So from here what we get is 45 M plus 1.5 N equal to 1.5 Mn. Okay, so if I cut with 1.5, this will give me 30 M plus N plus equal to Mn. This is one equation. And also using this relation for the maximum current, we are getting how much? R is given 30. N I don't know. R is 1. M I don't know. That means N is equal to 30 M. So let us put here 30 M plus 30 M is equal to Mn. 60 M equal to Mn. That means N is coming 60. That means there should be 60 cells in series. Now how many rows shall I make? So if I use this formula, that is, we have already got a formula. What is the formula? N is equal to 30m. So this is 60, 30m. So m is equal to 2. That means there will be 2 rows. 2 rows, and in each row there will be 60 cells in series. There will be 60 cells in series. Clear? So this was the question. How many cells should I use it? So friend, let's see. N identical cells are joined in series with 2 cells A and B with reverse polarities. That means here there are n cells. So these are n cells, each of EMF E, okay, n cells. These are connected to 2 cells with reverse polarity. A and B. Okay, so they see how they are connected, reverse polarity. That means positive with positive, connected positive to positive. This is also EMF E, and everybody has an internal resistance R. What is the potential difference across the cell A or B? Okay, so see, in the upper part the net EMF is how much? NE, and in the lower part the net EMF is how much? 2E. So since they are connected opposite, so this is the net EMF. Okay, now net resistance will be how much? It will be NR plus 2R, net resistance. So what is the net current? This is the net current. Okay, so if this is the net current, they are telling what is the potential difference across cell A or cell B. Okay, so if this is the net current, the current entering into this part, the current will enter into this part. Clear? So that means the voltage across A will be actually E plus this I into the R. A or B, E plus this. This is the voltage across this. Clear? Or voltage across B will also be same thing. Because current is entering into the cell, and I told you when current enters through the positive terminal, the EMF will increase by IR. This is the logic. Okay, so friends, we have covered up the first part of the, we have covered up the part 1 of the electricity. We have covered up part 1 of the electricity. We will be next doing part 2. Very soon I will be giving you a video of the part 2 also. So before doing the part 2, please watch the part 1 very nicely. Okay, I have tried to discuss the maximum type of numericals with you. Some very good numericals I have discussed with you. So please go through the numericals and try to do them on your own. Okay, and regarding the theory, I have covered up each and every theory which is there in this part. So there is no need to do anything extra. I have covered up the maximum theory from this part. So my suggestion is that please go through this class, go through this theory and try to do the numericals on your own. Okay, and if you are pleased, please understood it, and if you have liked it, so please I would again like to request you keep like, share and subscribe, please do. Okay, because you are watching Parijat sir classes. Parijat sir classes. So please like, share and subscribe, do it, and try to share the video among others. Okay, so till the next class we'll again meet again for the sessions. This was part 1. This was part 1, as I am telling you, part 1. Then for part 2 I will be bringing up the video very soon. Okay, so till then, before we again start with part 2, till then it's goodbye from my side and thank you so much.